Hi everyone. In this lecture, I want to continue different type of addressing modes such as direct, indirect, and index addressing in PLC 5 and SLC 500. So the direct addressing is what you have learned up to here. For example, when you want to use an integer number in your integer file and you want to address to that location in memory, the direct addressing is something in this form. So, for example, n7:1 will refer to your n7 file. Let's assume that this is your n7 file. And n7:1 means the second element in this memory table. So the first element is going to be n7:0, and then the next one is going to be n7:1. So this is the memory location that we can address by this direct address of n7:1. Now let's assume that we want to address to the same memory location. Let's see how the indirect and index addressing can happen in PLC 5 and SLC 500. Okay, so let's see how you can do the indirect addressing. First of all, what is the symbol for indirect addressing? In PLC 5 and SLC 500, you can figure out that there is some indirect addressing involved as soon as you can see a bracket. So bracket is a sign for indirect addressing. Now, inside your bracket, you need to have a logical address. You have to go to that logical address, and then you have to find the data in that logical address. And instead of the bracket and the logical address inside the bracket, you have to replace it with the data. So for example, if you have an equal instruction, then it means that you need to compare source A with source B. Source B is a data, so source B is 13, but the data that you need for source A is located at this address. Now, I'm going to write the address here. Your address is n7:, and then I have a bracket. Inside bracket, I have n7:2. Okay, I need to figure out what is the data that has an indirect address in this form. In order to do that, you have to notice that there is a bracket, and inside this bracket you have a logical address. So what you're supposed to do is that you have to go to the logical address you have inside bracket and find the data that is saved over there. So in n7:2, the data that I have is 5. So now what should I do? I have to replace both the bracket and the logical address inside the bracket with the data that I found at my address inside the bracket. So instead of both of these two, I'm going to replace them by 5. So let me simplify what I have here. What I'm going to have is n7:5. So instead of bracket with the address inside the bracket, I replace it with its data, which is 5. So this is my direct address now, which is n7:5, and that's the address to n7:5 here. So my data is equal to 13. So instead of what I have here, I can write 13. So this address, this indirect address that I have in front of source A, refers to 13, and consequently the result of this equivalent is true because source A is equal to source B. Now let's look at another example. In this example, again, I have an equal instruction with source A and source B. Source B is equal to 8, so I need to compare my source A with a number equal to 8. Now, for source A, what I have is an indirect address. How I know it's an indirect address? Because I can see that there is a bracket in my address. So let's write the address here and see what is the data in this indirect address. So my address is N7 colon bracket T4 colon 0 dot ACC. So what should I do? So first, I have to look inside the bracket. Inside bracket, I have a logical address which is referring to the accumulator value of my T40. So first I have to go to timer file. The first timer, which is timer 0, has an accumulator. I have to check the accumulator of T40. Let's assume that I know this number and T4 colon 0 that ACC is equal to 7. Now it means that I have to replace the logical address and its bracket together with the data that I have in the address inside the bracket. So I have to replace both of them with 7. So it means that my direct address is N7 colon 7. So if I look at my data file, in integer file, I have N7 colon 7 here, and the data at this location is 10. So instead of everything that I can see here, I can replace it with 10. So now 10 is not equal to 8. So this instruction does not have continuity. It is important to remember that the indirect address can be used for file number, it can be used for word number or element number, or even the bit number. And you can have more than one bracket inside each address. So you're not limited to only one bracket, you can have 2 or 3 brackets for different part of your address. Any part of a bit or word address can be used with indirect addressing notation, and the bracket is how you can figure out that you are dealing with an indirect addressing. Now let me show you a couple of examples for indirect addressing. So this table is showing you a bunch of different valid indirect addresses. Let's look at them together. The first one is referring to integer file. But which element? In order to find the element, you have to look at the accumulator value of counter 8, and then the data that you have for the accumulator value of counter 8 will come in front of N7 colon, and then you can find your address in integer file. Or another example is this one. So here you have 2 brackets. Now, for one of them, you have to look at your designated integer file. So then let's assume that this is your N7 and this one is your N7 colon 4. So this is what you need to use for N7 colon 4. And then you're going to have N, whatever data you have here. Let's assume that the data here is, for example, 10. So it's going to be N10 colon, and then you have N9 colon 3. So this time you have to go to file number 9. This is not a designated file anymore. So the reason that you can see something like that as N9 instead of N7 is that your N7 or your integer file is completely consumed and you are using the remaining files for your data. So that's a user-defined file. So here you have to look at your N9, and this time you have to look at element 3, so N9 colon 3, and whatever you have here basically refers to the address of the inside bracket. So let's assume here we have 8. So then instead of N9 colon 3 with its bracket, I'm going to replace it with 8. So this is going to be the direct address that this indirect address is referring to. So as you can see, there are a lot of different ways you can use indirect addressing for your input as well. So here you can see an example for input. So what you can see here is I colon, and then you have a bracket. You have to look at your N7 file, whatever number you have at the very first element. Let's assume that this is 2. So then it's going to be I colon 2.1/4. And now let's go to index addressing. Similar to what we said for indirect addressing, there is a symbol that shows you that you are dealing with index addressing this time. And this symbol is £. So a £, can show you that you are looking at an indexed address. So whenever you have an index address, what you need to do is that you have to add whatever you have at your S:24 to your current address, and then look at your memory table. So for example, let's assume that you are saving a value of 6 at your S:24. Now, if you have a move with mask instruction with 2 addresses which are index address, so your source is an index address and your destination is also using index addressing format. What you need to do is that you need to add 6 points to your current index address. So I'm going to write it here. So £, and then N7:8 is an index address, and it means that I need to add whatever I have at S:24 to this address. So I have 6 there, so it's going to be equal to N7:14. And for my destination, which is £, N7:13, then my direct address, so here I'm showing you the direct address related to these index addresses, is going to be N7:19. So you can replace them with these addresses. So I can replace this with N7:14 and the destination with N7:19. The only thing that you should be careful about index addressing is the fact that index addresses must be inside a file boundary. So if you have a file, then your address should remain inside the file boundary. For example, let's assume that at your S:24 you have a value equal to 10. So this is what you have at S:24. And let's assume that your N7 file has only 20 elements. So what you have in your N7 file is element 0 up to N720. So this is the boundary of your file. Now let's look at this particular address that we have here. This is an index address, which is £N7:15. Now because of the pound, it means that the program should look at the value at S:24, which is 10, and it needs to change the pointer. It should increase the pointer by 10, so the direct address equivalent to this address is N725. And this is something outside of the boundary of this file, so because of that, a fault will be generated. So you should be careful about your addressing, about your index addressing, to remain within the file boundary.